Okay, we're going to look at PLC memory types on the Click PLC. And in that, we're going to learn that there's different types of memory. First, we need to look at the nomenclature. There's integer numbers, which we know as whole numbers. Whole numbers are 0 and 1, no decimal point. But we have some special names. We call a bit is 1 bit. It's on or off, and the values are 0 or 1. Now, if we take 4 bits together, it's called a nibble, and that'll make sense in a moment. It's 4 bits. It's a grouping, 4 bits together, and they can signify the number from 0 to 15. We get that because if we take 2, which is the possibilities of a bit, to the power of 4, we get 16. Counting with 0 makes 16 possibilities. 8 bits, which is 2 nibbles, hence it's called a byte, and that's why half of a byte is a nibble. We get values 0 to 255 or 256 unique values. A word is something that is 16 bits, in other words, a double byte, 2 bytes, and it can store 0 to 65536, and that is 64K. 64,000, 64 meg, that's where we get this kind of linking of numbers. Double word, 32 bits, 2 words together, which can store like 0 to 4. Well, that's more than numbers I ever seen in a bank account, but 4 million they tell me. So, floating point is one other type of number, and in the Click it's 32 bits, but it can hold decimal points. We'll talk about that in just a moment. So, learning these numbers, a bit can't store the number 5. You can do that in any of these others, but you can't store it in a bit. So that's why as we move now into counters and timers, we need to learn about this memory. Data is defined as any value greater than 1. In other words, not a bit. It allows us to count or tally, to measure things, to time things and count seconds or days, store things like the date, birthday, a barcode number, or something going down the line. And data values are used in PLCs in our lives all the time, so it's a natural fit. Now the Click has memory types, and this chart shows us the types of memory. Under the bit type on top here, we've seen X, Y, and C. Now we learn there's up to 800 X's, we'll define that, but each number here can be another module. But in C, the internal relay coils, or the control relays internal bits, there's 2,000 of those to be used. Timer bits, which says a timing event is finished, is 500 of those. So you can have 500 different things you're timing. Counter bits, you can have 250. And this would tell you that. And we haven't looked at the system control relays, built-in ones, and they have a series of 1,000 of those, which tell us. And the data memory addresses now, we're just going to look at CT. Remember, that was a counter bit. That says the counting's done. But down here, CTD, the counter current value. Oh, how many cars have come into the parking lot? Again, there's 250, but see this D? That D means data. As compared to here, it just means the count status. It's a double word integer, which means it can store a very large number. Okay? And it's retentive, which we'll learn about later. It's still there after we turn on and off the computer or the PLC. Now, the Click data types, this is what they fit in. There's an I2 and I bit. So the bit, this is similar to the table. These were the X's, the Y's, the C's, the CT. Integer is like the DS, DD. So if we look at this, we look here, and we go back one, we can see these notations here. So we can see a timer can't hold its biggest value as a counter. Okay? So a DS could hold only what value? Well, up to this value Now I said 64K on the other side, and that's what's here, but they're using positive and negative, so they split it in half. Same here, we've got 2 million negative, 2 million positive. So quite a wide range of values. There are other ones we'll get to later. Text, hex we might see, but text we may see. We want to send something out to a display that's communicated in what we call ASCII characters. American Standard Code for Information Interchange. Example of using data. So if we were to add 5 plus 3, we could store that in a DS or a DD memory. However, if we were to add 200,000 plus 1.2 million, we would have to use a DD memory, because if we put it in a DS, it can only go up to 65,000 or 32,000 we saw, and it would just lob off that data. And if we do a calculation like 12 divided by 5, which equals 2.4, we'd have to use a DF. If we used a DD or a DS, we'd only get the 2. So programmers take care of these things. So if we look at counter memory, we can see here how it works. CT for counters, I talked about the counter bit. CTD, that means data. It's a double word, and it shows it can store this number. So that's just an example of why we need to know it and what it needs to be called. So that takes us through just an overview of counters. We got to these slides by looking in the help file at either the data memory or the data types or the memory addresses.